This video presents the 5 pillars of mechanical engineering, a first principles framework for solving most engineering problems. It moves beyond classroom equations to share the mental operating system used by expert engineers. There is a disconnect between school and practice. Engineering curricula treat statics, dynamics, thermodynamics, and fluid mechanics as separate subjects. In reality, real-world problems cross these boundaries. To become an expert, you must see the universal patterns that govern them all. The first pillar is balance laws, which establish feasibility. Before you design, you must balance quantities that cannot disappear, such as mass, momentum, and energy. If the balances don't close, the design cannot exist in the real world. The second pillar is constitutive relationships, defining system response. Balance laws tell you what must be conserved, but not how a system responds. This response is defined by modeling choices, such as stress-strain laws, viscosity models, and heat transfer coefficients. The third pillar is degrees of freedom and constraints, ensuring control and stability. Every system has a finite number of independent ways it can move, deform, or change state. Constraints limit these possibilities, telling you if a system is stable, controllable, and physically realizable. The fourth pillar is trade-offs and optimization, navigating competing realities. Every design exists within competing constraints, like weight, cost, and stiffness. Improving one metric almost always degrades another. The engineer's job is to find a viable compromise. The fifth pillar is limits and failure modes, defining the boundaries of operation. Every system has a breaking point. An experienced engineer understands which failure mode governs the design and ensures an adequate margin relative to that limit. Solving complex problems requires an integrated engineering mindset, stacking these 5 layers. You must check balance, define constitutive models, set constraints, analyze trade-offs, and finally, check limits for safety. Most mechanical engineering problems are hard not because they are complex, but because it is unclear what governs them. When you are stuck, the governing principle is ambiguous. Identifying the specific balance, constraint, or limit makes the path forward clear. These 5 ideas, balance laws, constitutive relationships, degrees of freedom, trade-offs, and limits, are the DNA of mechanical systems. Master them, and you can solve anything.